Hello future engineers, how are you all? Welcome to our channel Diksha Karnataka, where learning is fun and not just fun. We are able to produce a very good result that we'll talk about in detail later in the session today. Okay, so now this is the platform where your formula meets tricks. Why is that? So because we are studying for any competitive examination, right? Whether it is JEE, whether it is NEET, CET, whatever it is, okay? So for all these examinations, there is a time bound, so you have to be precise and quick in your answers, okay? Of course, because of the workload that you have across your preparation, you need to have, of course, that creates a stress in your, in the preparation journey. For that, you need strategy. So on our platform, we provide you all the strategy that is required to make you excel, to make you achieve your goal that you have set for yourself. Okay, so without wasting any more time of yours, let's begin with the session right away. So today we're going to talk about relation and function. This is again the part 4 of this chapter. So part 1, 2, 3, what we have done, we'll see all of that. Part 4, we're going to discuss relation and functions, JEE Mains PYQs. When I say JEE Mains PYQs, so for all the the recent years questions, for example from 2024, 2025, I've taken all the PYQs from this chapter. I hope that works out. Okay, let's see what we have next as the planner. We know that very well. So in the part 1 of this chapter, the session that we had in the chapter relation and function, we were discussing types of relations. Then when we went to the part 2 where we discussed types of functions, then part 3 we discussed KCET PYQs. In today part 4 we'll discuss JEE Mains PYQs, and that's the structure of our Sankalp batch as well. So we have concept sessions first, again succeeded by we have KCET PYQs, JEE Mains PYQs coming next. Okay, so I hope this is clear, very much clear. So we have concept first, then the PYQs of CET and JEE Mains separate. Again, we'll do chapter wise and we'll try to keep as many questions as possible. So today I'm taking almost 20 plus questions. Okay, so that will be good enough to understand the concepts of these questions. When I say concept, I mean that what kind of concepts are used in the questions solving. Okay, so we'll analyze all of that. We'll learn from just the questions itself. So let's see what we have next. So we have, as I said, we'll talk about our results also. Okay, why it's very important to talk about a result? Because these students deserve to be talked about. Okay, they have worked so hard, they trusted us, and they were able to produce. Prajwal got 171. Kiran, we met Prajwal, as of course we had a small ceremony over here. Kiran got 443. Diksha also came 693. We had Samiksha 752 and Sachin Shastri at 934. There were many more. Actually, you can see over here 1197 all the way to 5534. There were many rank. We can't even put it on the screen right now over here, but you have seen our results video. There we have disclosed all the ranks, all the details that was available given to us by the students. Again, the best thing about all these results is they're completely authentic. Okay, means Diksha has been known to produce authentic results year and year for last 25 years. Okay, that's the brand of Diksha. That's the value that we have added to the society of the students. We have helped the students in various ways, in various examinations across all the competitive examination that is available in our country. And now, what is our goal? Our goal right now, I've assigned that to you in the first session itself. The goal is your name, your picture should come in this place as a next set of toppers, rankers in the next year of examinations. I hope that is clear. Let's begin. So as I said already that we have 20 plus PYQs to solve today for JEE Main from the paper 2024 and 2025. Okay, that's not a problem. So let's begin with the question number 1. That works out. Let's see. So in the question number 1, what we have? A simple question, just language based. Just try to focus, give your complete attention on the board, and you'll be able to understand this question very, very clearly. I am gonna repeat myself. All your attention on the board. Keep your pen down. Don't have to write anything right now. Okay. I'll provide you the notes also. What are you going to do for the notes? If you are already joined our WhatsApp channel, you know that very well. But if you are new watching this video, for the class notes, we provide all the PDFs for free. Of course, the entire Sankalp batch itself is free, and what you're going to do for that, you have to join our WhatsApp channel. Okay, don't worry about your privacy. You will not get any of your data. It's a channel, not a group, WhatsApp group. Okay, so we'll just publish our content on the channel. You get to receive and download it. Okay, so the class notes in the PDF format will be provided over there. Any update coming regarding the sessions, scheduling of the sessions, any update regarding any live sessions will be given over there only. So please join the WhatsApp channel. The link for that is given in the description of this video. Make sure that you have joined it and getting all the updates. So notes also in the WhatsApp channel. Works. So question number 1, please put your pen down and solve this question with me just by your mind. Okay, so the question is, let A be the set of all functions defined on integers z to z, right? Integers is defined on and R be relation on A such that, okay, so the relation is defined as f comma g. The ordered pair is the relation. okay, such that F0 is G1 and F1 is G0. That's the relation definition, okay? So we have to keep this in our mind. F0 is G1 and G1 is, F1 is G0. Very specific, they have mentioned the numbers also, F0, G1. We can't use F2 or something like that, okay? So basically F0 is G1 and F1 is G0. That's your relation definition. Clear? Let's try what you're looking for. Okay, we're looking for types of relations over here. The question is, this would be reflexive actually. Reflexive. So what we have, symmetric, transitive, but not reflexive. We'll see the options once we solve it. Okay, so let's try for reflexive first. Let's try for reflexive first. So for that, what we're gonna do, we're gonna take the relation to be, of course, F comma F. That's what we do in the reflexive. That's the ordered pair, how it looks like. Remember ordered pairs of reflexive, A comma A, ARA. Remember, that's how we write the symbol also. ARA is the notation for reflexive relations. Okay, ARB, BRA is relation for symmetric one. Okay, so ARA I have for reflexive. Let's write that. For that it will become FG will become FF. Now think about it. For that we have to write here F0 equals to F1, and will this be possible? F1 equals to F0? Not possible, because they've said that F0 is G1, not F1. Okay, it means it's not possible. We can't have reflexive clearly. Correct now? Think about it. F0 is F1 only possible if it is given as G1 and G0 is equal. Have they mentioned anything like that? Have they mentioned to us that G1 and G0 is equal? They have not mentioned anything like that. We can't say that F0 is F1 equal to each other. Okay, so of course we have to state that clearly over here. It's not reflexive. Moving on to symmetric. Check this out. To symmetric, what we have. Okay, I think this works out. So if I take FG, if I take F comma G, right, if I take F comma G, so I'll have the same condition what is written over here, F0 G1 and G0 F1, sorry, yeah, so we have F0 is equal to G1 and we have G0 equals to F1, right? Okay, now if I write the symmetric, means this is the condition for FRG. I should write here GRF also. That's how the symmetric goes. If, then this should also be true. It means that you should have here G0 should be equal to F1. That's how the relation goes. Please see here G0 and F1. Okay, next it should become what? And also we have G1 equals to F0. Correct now? G1 equals to F0. We are changing the position. It was FG over here, now it is GF. So I have to take G first, right? So check this clearly. We are getting the same statement. G0 F1 is over here and over here, so works out. And we have G1 F0, G1 F0 over here and over here. So works out. Okay, it means symmetric. It's a symmetric relation. That's what it means, symmetric. Put a tick on this. Okay, let's take the last one, which is transitive. Not difficult at all. Okay, so for the last one we'll have to check for what. So I'm going to write here first FG. So I'm gonna, if you want, I can write in this format. Okay, easier for all of us to understand. So FRG, then I write here GRH. These are the two given statements, which is true. I have to prove that FRH is also true. I have to prove that FRH is also true. This is our condition, right? These are two given conditions. We have to prove this is also true. Let's check this out. So what we have FRG. From here I get F0. Excuse me, my mistake. So we have here F0 equals to Z1, and we have G1 equals to, okay, so G0 equals to F1, forgive me. And for this part we have, what is it? We have a Z0 equals to H1, and we get here G1 equals to H0. Okay, now I'm gonna use these two results that I have, two equations over here, two equations over here. Check this out. So I have H1 G0, I have F1 G0. Okay, it means H1 and F1 are equal. Think about it. Okay, we have G0 equals to H1 and G0 equals to F1. It means from here you can say H1 and F1 are equal. H1 and F1 are equal. Okay, just give me 1 second. H1 and F1, right? H1 and F1 are equal. Yeah. Okay, so we get F1 and H1 equal. Next, what we have? So we have here G1, it means F0 and H0 is equal. So we have F0, excuse me, let's take some silly ones. So we have over here F0 and H0 is equal. But you know that to prove FRH, we should have F1 H0 and we should have F0 H1. Is this the same thing? Of course not. It means not transitive. Remember this. If it was to be, if the function was FH, I'll write here F0 H1, F1 H0. Okay, is that coming? No, sir. We are getting F1 and H1. We can't say that is true. It means we are not getting the statement true, right? So we can say simply transitive also not possible. Only symmetric is the condition. So option is only symmetric, right? Symmetric but neither reflexive nor transitive. Option B is correct. I hope you didn't find this too messy. The question statement is like this only. We have to prove it. More theoretical than problem solving with the help of formulas and equations. This is more of a theoretical problem. I hope this is okay. So first we proved for reflexive. I hope this is clear. Then we moved on to symmetric part. We got that is right. And the last also transitive didn't come true because for FRH we should have what dear? We should have F1 H0 and H1 F0, right? Correct. So this is clear, which is not coming in this particular case. Moving on to the next question, what we have, please check. I hope this is clear, right? So first you see this question 1, clear. Okay, don't worry about the notes. You're gonna get it very simply in the class notes PDF. Okay, join the WhatsApp channel. Now question number 2, another very simple question. Let's read it out first. First thing is to any JEE questions is very important to understand the question statement, because what happens it might look something that okay you've done it, but they might have tweaked the problem statement over there and get you to choose that negative option, right or wrong option, and get negative marking. It's very important to read the question very, very clearly and give your time for that. It's one of the most, it's like basically part of solving the question. Reading it properly is very important, okay? Because negative marking is there, okay? Let A equals to -3, -2, -1, 0, 1, 2, 3. That's the set defined. It's not, the bracket is wrong over here, sorry. It's the curly bracket because you want individual terms, right? It's a set. Let R be a relation on A defined by X or Y if and only if, okay, the condition is x square plus 2y is less than 4 and more than 0, okay? So x square plus 2y should be less than 4 basically, and of course greater than 0 has to be there. So if you check over here, -3 if I take x as -3, what I get as y? I get y as, if I take y as -3, excuse me, let me do it ulta. If I take y as -3, that works better. If I take y as -3, think about it. We get here -6 goes on that side. 2 into -3, -6 goes on that side, becomes +6. So 10. So we get from here, you can see, I'm getting here x square is less than equal to 10. It means I can take x value as simply -3, 3. Okay, I'm taking only these two. I'm getting the x value as -3, 3. Okay. Again, this is not this bracket. Let's change that. These are curly brackets, okay? That is clear. The middle brackets. Let's try again. For y equal to -2, what do you get? For this we get, please check. Clearly for this we'll get -4 plus 4 becomes 8. So we'll have -2, 2. I hope this is clear, right? I can do the calculation faster. I hope that is okay. Put here 4 plus 4, 8. So of course we can't have the root like that. No, we can have -2 and 2. Let's put now y equals to what is it? -1, right? Y equal to -1. What are we looking for? Let L be the number of elements. Okay, so we're looking for L actually. We're looking for number of elements L. I'm writing all the ordered pairs actually, and M be the minimum number of elements required to be added in R to make it reflexive. Okay, so we'll get the first relation. So trying to do what? Trying to write the relation actually. The relation R is defined on the set A. I'm writing all the elements in the relation R. Okay, for that I'm getting all the ordered pairs. Okay, so y equal to -1. If you check, what you're gonna get? You'll have again this will become plus -2 goes on the over here becomes +6. So again I'll have the same thing, -2 and 2. Now put here y as 0. Putting y as 0, I get what? X square less than 4. I can get x value as, of course, -2, 2, even 0 okay, and -1 and 1 also okay. Correct now? Okay. Even you can put -1 and 1 over there. Okay. Please check. If you put x as -1, again it will become 1, which is less than 4. And if you put 1 also, again is going to be less than 4. If you put 0 also, condition is true, less than 4 and more than 0. Okay, so that is correct. Let's move on now. Again, we can use it anywhere, but don't worry, we'll get the same ordered pairs. If you want, you can use any other places. You'll get the same ordered pair. You can't repeat the ordered pairs, right? Can you repeat the ordered pairs? You can't repeat the ordered pairs. Okay, the elements cannot be repeated in any given set. So y is 0, and next moving on to y is 1. If you put y as 1, we get to -2. So we get x as basically -1, 0 and 1, right now? Because this will become this will become 2 over here. So 4 minus 2 becomes simply 2. So we have the answer as -1, 0 and 1. Okay. Next we get y as 2. So from here what we're getting, it will become 4. So this will come 0. I'll have x as simply only one element, 0. If you put y as 3, what will happen? It will become 6. 4 minus 6 is how much, sir? -2. We cannot. Can we have x square equals to -2? Never. It's a positive number, right? So we don't have to do for y equal to 3. For y equal to 3, there is no x that is existing in nature. That's your ordered pair. Let's write it down. So what we're getting for it? So we're getting over here. Please check. -3 -3. First one. I'm writing the relation R actually. So -3 -3. Next we have -3. 3 minus 3 actually. 3 minus 3, no? Yeah. 3 minus 3. That's from the first one. Next we have -2 and -2. -2 and -2. And we have 2 and -2. So we have here 2 and -2. This is done. So this is done. And this is done. Okay. Let's move to the third one. We have -2 and -1. And we have next what? We have 2 and -1. Okay, and this is also done. Let's just be focused over here. It might take time, but very easy question. -2 and 0. -2 and 0. Okay, next we have 2 and 0. Okay, next we have 0 and 0. Next we have -1 and 0. And next we have 1 0. Okay, this also is done. Great. Moving on over here, we have -1 and 1. Okay, and then we have 0 and 1. Okay, and then we have 1 and 1. Okay, and what else we get? So we get last is simply 0 and 2. Okay, correct. So this was done, and this also is done. Check the number of elements over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'm getting the value of L is 15. What is L, sir? L is the cardinal number of the set R. What is set R? R is a relation actually. Please check. L will be the number of elements in R. It means the cardinal number, right? So L is 15. Now we're looking for to make reflexive. For that we need the M value. What we're gonna add? So for M set, please check. So we have, what do we have? So we already have, sir, -3 -3. We have -2 -2. Do we have -1 -1? We don't have that, right? It here. We want -1 -1. Okay. Do we have 0, 0? Yes, we do. We have 1, 1. Yes, we have 2, 2. No, we don't have 2, 2. Okay. And do we have 3, 3? We don't have that also. Okay, so basically check the elements: -3 -2 -1 0 1 2 3. Okay, so we have 1 2 3 4 and of course 3 over here, so 7. Total 7 symmetric elements should come, right? So not symmetric, reflexive elements should come. -3 -3 -2 -2 -1 -1 0 0 1 1 2 2 and 3 3. So the other 4 is over here, the 4 ticks you can see, and 3 I've added. It means M value is simply 3. So what I'm looking for is L plus M. I'm looking for L plus M. Add them, you get the answer to be 18. Your option is D. Please check. Your option is D, 18. Okay, so yes, it is little lengthy. Not lengthy, if you can do it in your mind, good for you, but I wanted to show for everyone. That's why it's might have taken a little longer, but simple question. Won't you all agree? It's a very simple question. Question number 2 is done. Question number 3 coming for all of you over here. So let A equals to -2 -1. Again, as I said, read the question first. Don't presume anything in the question. It might give you a wrong answer and negative marking. I hope this is clear. Okay. So -2 -1 0 1 2 3 R be the relation on the set A defined by x r y if and only if y is basically max of x and 1. Max of x and 1. So how you write the relation? So max, so y is going to be max of x and 1. So let's write here minus 2. So will be minus 2, and max of minus 2 and 1 is how much here? 1. Getting it? So the y coordinate of the ordered pair, I repeat myself, the y coordinate of the ordered pair. What is the ordered pair, sir? The ordered pair of the entire relation R. For the entire relation R, we'll have ordered pairs, right? They have given here, no, x or y. Please check. Okay, that's the ordered pair. So in the relation R, the ordered pair which is there xy, x is the element of A. That's okay. But y is max of this x and 1. If you put max of minus 2 and 1, what is the maximum of those two? 1 is the maximum. So we get here minus 2, 1. Again, minus 1 and 1 will come because minus 1 is the x, and maximum of minus 1 and 1 is 1. Great, sir. Moving on. Next we have 0. Again, we'll continue with 0 and 1. Now check here. 1 and 1 will come. Excuse me, I made a mistake. So 1 and 1 will come. Now the thing changes. 2 is the x. Okay. 2 is the x. What about y? Y is nothing but max of x and 1. X we put as 2. Max of 2 and 1 is what? 2. Getting my point? So x value, check for the next one. X value is 3 over here. So right here, 3. X value is 3. And max of 3 and 1. Put for y, you want max of 3 and 1. So we'll again get 3. That's it. Okay. So now what are they asking? This is the L value, I think. Okay. Let L be the number of elements in R. The number of elements basically is called as NR. This is your basically L. The cardinal number of the set R is going to be L. And how much is this? 1, 2, 3, 4, 5, 6. So 6 is the value. This is clear. This is clear. I hope this is clear, right? This is clear, no problem at all. Next, so number of relations, M and N be the minimum number of elements required to be added in R to make it reflexive and symmetric. So M is for reflexive and N is for symmetric. Let's do reflexive first. So let's try for M now. Okay, the reflexive statements, what we are missing here. Do we have minus 2 and minus 2? We don't have. Okay. Do we have minus 1 and minus 1? We don't have. Do we have 0 and 0? We don't have. You don't have 0 and 0, right? And do we have 1, 1? We do. 2, 2 we do. And 3, 3 also we do. It means your M value is nothing but, from here you can conclude, your M value is nothing but 3. M value is 3. Let's look for N value. Let's look for N value. Okay, so the symmetric part, symmetric we can see from here minus 2 1 is there, means I need 1 minus 2, correct? Now if I have minus 2 1, I have to make it symmetric, I need 1 minus 2. Okay, minus 1 1 is there, I need 1 minus 1. 0 1 there is mean I need 1 0. Anything else? 1 1 2 2 3 3 already symmetric. Okay, it means again N also is 3. So your answer for L plus M plus N, check here, is 6 plus 3 plus 3. That's simply 12. Option A is correct. Option A is correct. I hope this makes sense. Simple enough. Very simple. All of you will agree. Okay. Moving on to the next question, which is question number 4. So I hope you are able to see the pattern of the questions now. Okay. The analysis you will be getting how the questions are there, because it's very important to have your own analysis of your paper. Okay, from this chapter, relation and function. Okay, sir, they're asking this kind of question. Okay, so maybe I should prepare for these questions more. Getting my point? Okay. So let me know your feedback. What do you feel about the session in the comment section of the video? Of course, you know that I'll be interacting with all of you. Okay. So another question. Let A is minus 3, minus 2, minus 1, 0, 1, 2, 3, and R be a relation on A defined by X R Y. Again, ordered pair X R Y. Okay, ordered pair X comma Y. Yes. Okay, relation defined like this, 2x minus y can either be 0 or 1. They're saying that this can be either 0 or 1, right here? Can be either 0, can be 1. From here we can get what? Y equal to 2x. From here I get y equal to 2x minus 1. So your relation R, the ordered pair going in the relation R, has to be either following this condition or this condition. Correct now, because they're saying 2x minus y can either be 0 or 1. Why 0 or 1, sir? Because they are individual terms. Can you not see that? They are middle brackets. Okay, individual term either 0 or 1. When you take 0, you get y equal to 2x. When you take 1, you get y equal to 2x minus 1. Works? Yes. Let's use all of it. If I put x as minus 3, I get minus 6. Not possible, sir. Why not possible, sir? Because the relation R is defined on the set A only, na sir. R is defined on the set A, na sir. And if you take x as minus 3, you can do that. X is minus 3, okay. Y comes as minus 6. Is there a minus 6 in the relation in the set A actually? Is there a minus 6 in the set A? It's not there. We can't take that. Okay. So x equals to minus 3, we can't take. Can we take minus 2? Minus 4 will come as y. Can we take that? Not there, sir. Let's try from minus 1. So when I take x as minus 1, I get y as minus 2. That's one of the ordered pair. I'm writing the relation R actually. Please check. Relation R, I have, if I take x as minus 1, I can't take these two, right? I can't take these two. Explain you right now, okay? What I get the value of, when I take x as minus 1, y is minus 2. Great. When I take x as 0, that's simple. Okay. X is, okay, 1. I can take, right? 1 comma 2 is okay. If x as 1 means 2 into 1. I'm using thus the first function. I'm going to go back to the second one after completing the first function. Okay. Take x as 2. 2 to the 4. Possible? No. So again, I have to remove these two for the first function. This is clear, right? Okay. Next, we're going to move on to second function. Take x as minus 3. What we get? Minus 6, minus 1, minus 7. Can we take it? No. X as minus 3 becomes minus 6 over here. Minus 1 is minus 7. No. X as minus 2 becomes minus 4, minus 1. Minus 5, no. X as minus 1, minus 2, minus 1, minus 3, we can take that. X as minus 1 if you put x as minus 1 over here, it becomes minus 2, minus 2, minus 1, minus 3, we can do that because minus 3 is part of it. So our ordered pair will come minus 1, minus 3. Correct, na? Okay. Next is what, sir? 0. 0, you get simply y as minus 1. Okay. Next is what, sir? 1. 2 minus 1. So we get 1, 1. Put here x as 1. 2 into 1 is 2, minus 1 is 1. Next, put x as 2. 2 to the 4 minus 1 is 3. We can do that. So 2, comma 3. Correct, now? 2 into 2 is 4, minus 1 is 3. So x is 2 and y is 3. Okay. Put x as 3. 3 to the 6 minus 1, 5. Not possible. This is my relation then. This is my relation then. Please check how many numbers are there. 1, 2, 3, 4, 5, 6, 7. So basically my NR, the cardinal number of the set R, which is the relation actually, nothing but your L is coming as 7. This is clear. Easy or not? Very easy. Okay. Let's move on with the next part of the question, which is M and N be the minimum number of elements required. For M we need what, dear? Reflexive. And for N we need what? Symmetric. Okay, let's do reflexive first. So for M I am trying to write now. Okay, so I need reflexive, so I need minus 3, minus 3. Okay, I need minus 2, minus 2. Okay, from here, from the set A, I also need minus 1, minus 1. Do we have that? No, we don't have that. I also need 0, comma 0. We have that over here. Okay, 0, comma 0. We have it over here. So we don't need that. And 1, comma 1 also we have over here. So we don't need that. We do need 2, comma 2. And 3, comma 3 also, I think, right? So we have 1, 2, 3, 4, 5. So my value of M is nothing but 5. That okay? That is okay. Let's look for N now. Let's look for N now. Please check. So for N, we need to have symmetric, right? Symmetric. Check over here. I need minus 1, 2 means I need minus 2, minus 1. Okay. I need 1, 2 means I need 2, 1. So this one. I need minus 3, minus 1. Okay. I need minus 1, 0 from here. And I need 3, 2 from here. This all is symmetric, right? This all is already symmetric. Okay. We needed only symmetric for the elements in the, or basically the ordered pairs in the relation R. So which was this one, this one, this one, this one, and this one. Total 5. So what we have? N also is 5. What I'm looking for? L plus M plus N, right? Yeah. So we get here 7 plus 5 plus 5. How much is this? 17. Answer is option B. Option B. You can see the questions, the type of questions, and how it is easy to solve the problems. Easy or not? Very easy. Moving on to next question. Okay. So next we have question number 5. The number of relations on the set A 1, 2, 3 containing the at most 6 elements including 1, 2 which are reflexive and transitive and not symmetric. Alright, number of relation on the set. Okay, at most, very important word over here, at most 6. It means it can be 4, it can be 5, it can be 6. Why 4 only, sir? You'll see that now. So we have the we have the reflexive and transitive case. Okay, so first we write the relation over here. So reflexive, I'm writing the reflexive first. So 1, 1 will come, 2, 2 will come, and 3, 3 will come. Of course, for the set A, the reflexive will be 1, 1, 2, 2, and 3, 3. Okay, that is required, mandatory. We have to take the case of identity relation for sure in the reflexive. That we know that. Okay. Now, including 1, 2. This is also part of the relation. This is a mandatory. Okay, this is a mandatory. Okay, right now this given relation is reflexive or not? Yes. Transitive or not? Yes. I have taught you this in the session. If you have AABB, 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 we have AABB, and they have given you AB. Don't check for transitivity. Statement was don't check for transitivity, because it's going to be always transitive. It's going to be always transitive. If you have AABB, don't check for AB. It will be transitive. If you have AABB, AB is always transitive. I'll repeat myself. AABB, AB is always transitive. Okay, great. So with that known, it means right now the relation R is actually reflexive and transitive also. Okay. So with that known, with this known, how many elements are there? 1, 2, 3, 4. It means for 4 elements, for n equals to 4, okay, we have only one case. We have only one case or one possibility. Let's look for when n is 5. n5 means what? We have to add only one element over here. We have to add only one element over here. What we can add? We can add 1, 3, or we can add, can we add 2, 3 over here? We can't add 2, 3. If you are thinking add 2, 3, sir, it will not work. Put here 2, 3. If you put here 2, 3, from the property of transitivity, you will need 1, 3 also. Then you might think, sir, 1, 3 I've already taken. No. I have to take one at a time, no? One at a time. Why only one at a time, sir? Because we are looking for only n equals to 5. You already have n as 4 over here. We cannot have 1, 3 and 2, 3 together. Can we? We can't have that, okay? So if you are thinking of taking 2, 3, not possible. If you take 2, 3, it becomes 1, 3 also has to be there in the relation R to make it transitive. They're asking for transitive also. So we can't have 2, 3 over here. If you take the case as 2, 3, it's wrong, okay? So you have to remove the 2, 3 actually. Remove 2, 3 from here and from here also, okay? Rather you can write 3, 2, that will work. Right here, 3, 2. That's correct. Put here 3, 2, no difference. Because check again, we have A, B, B, A, B, or B, A, not a problem, okay? So 3, 2 also is possible. So we have two cases over here. We can write here 2 possibilities. Okay, works. 2 possibilities, okay. Moving on to n equals to 3. When the number is, sorry, not 3, 6. N equals to 6, sir. Over here we had number of cardinal number to be 4, cardinal number to be 5, and now we're moving on to cardinal number to be 6. Now in this case we can add 2 at a time. We can add 2 ordered pairs. Ordered pairs can be added, okay, at a time. Over here we had 1 at a time. Works? Okay. So now what you can do, please check. I can do, yeah, the beloved 1, 3 and 2, 3. That works. Putting here 2, 3 will give me 1, 3 is required. Already taken 1, 3 also here. Next will be what here? Unrelated 3, 1 and 3, 2. And we can take 1, 3 and 3, 2 also. All works. Please check. 3, 1 with 3, 2 also will be a transitive and reflexive. Okay. And 1, 3 and 3, 2 will also be transitive and reflexive. Okay. They are all cases. So we have total of 3 possibilities. Correct? We get total of 3 plus 2 plus 1. My answer is 3 plus 2 plus 1. Total number of possibilities. 3 over here. Please check. 3 over here. We have, please check, 2 over here and 1. 3 plus 2 plus 1 is 6. 6 possibility is the answer. Answer is 6. So I'll write here. Answer is basically 6. So we have total 6 such relations which will be based upon the set A, which will be reflexive, symmetric, which will be reflexive, transitive but not symmetric. Works? Okay, have a look. This is clear. Okay, moving on to question number 6 now. Okay, so question number 6 now. Okay, I hope so far it's going good. Acha, one more thing I want to know is you'll tell me about the pace and all. Okay, I'm trying to explain you everything in detail. If you don't want that, let me know in the comment section. Sir, you want to go, you can go faster, you can go slower, whatever it is, you let me know in the comment section. We'll figure out a way to incorporate all of your wishes. Okay, question number 6. Let A equals to 0, 1, 2, 3, 4, 5. Let R be the relation on the defined. Okay, if and only if max of x and y should be either 3 or 4. So basically for the ordered pair xy, this is a relation, right? X or y is the relation. So for ordered pair xy, always there should be maximum of 3 or 4. Means in either of the x or y, one should be maximum and it can be either 3 or 4. Let's writing the relation. So relation can be written like this. First element, sir, 0, 3. Maximum, was that maximum, sir? 3. Okay. 3, 0. Maximum, sir? 3. Okay. 0, 4. Maximum, sir? 4. Okay. 4, 0. Maximum, sir? 4. Getting my point now? So the maximum of the x and y has to be either 3 or 4. Why either, sir? Because of the middle bracket you can see over here. Clear? So now similarly you can write 1, 3, 3, 1, 1, 4, 4, 1, 2, 3, 3, 2, 2, 4, 4, 2. Okay? Okay. Next we have 3, 3 and we have 3, 4. 3, 3 and 3, 4. Of course, the maximum has to be either 3 and 4 is always validate over here. You can see in every ordered pair, the maximum is either 3 or 4 only. Okay, next what we go? 4, 3, okay, and 4, 4. Can we go beyond that? Can we use this one? 5 also we can't use. It will become maximum is 5. Okay, so number of, check the elements in the relation are, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So basically your n are the cardinal number of the set R. Even the R is a relation is also a set. Okay, will have the elements as 16. Please check. 18. So wrong. Number of elements in the relation R is not 18, it is actually 16. So statement 1 is wrong. 2, the relation R is symmetric. Yeah, symmetric only, no? 0, 3, 3, 0, 0, 4, 4, 0. Symmetric but not reflexive. It's not reflexive, of course. We don't have 1, 1, 2, 2, 0, 0. We don't have all of that. Okay, and nor transitive. We can't say transitive also. Okay, so of course, statement is only S2 is true. Option C is correct. Only S2 is true. Simple question. Very simple. Moving on. Let's move on to next question. 7th one. The number of non-empty equivalents. This is easy, right? Non-empty equivalents. So we can write from here. First one is 1, 1, 2, 2, 3, 3. First is the equivalence or not? It's equivalent, sir. It's reflexive. It's symmetric also, and we can't check for transitive, so it's also transitive. The relation R over here is actually equivalence and it's non-empty. Okay, it is non-empty. You can see that over here. So second R2 you can see. What you can do in R2? Include 1, 1 letters. I'll show you. So keep 1, 1, 2, 2 and 3, 3 over here, and one ordered pair you can keep 1, 2. Then you can keep here 1, 3 and 2, 3. So you have 3 such cases over here. 3 cases over here. Okay, 1, 2, 1, 3 and 2, 3. Works? All right. Okay, great. So next, moving on, we are R3. Moving on here with R3, what we have? So we can have here all of them. Okay, we can have the entire set. So we can have 1, 1, 2, 2, 3, 3, 1, 2, 1, 3. Okay. Then we have 2, 3. Okay. And then we have what? We have 2 1 3 1. They have to take the case of, okay, I forgot to write here. We want symmetric also, right? 1 2 if you keep, it will become transitive but not symmetric. So keep 1 3 and 3 1 also. I hope this is clear, right? That is understood. That is understood by your by your own. That's a understatement of equivalence relation. The statement of equivalence relation clearly. Okay, 1 2 means 2 1 has to be there for it to be symmetric. 1 3 means 3 1 has to be there. Or 2 3 means 3 2 has to be there. Works out. Okay, so for 2 1 3 1, and again we'll have 3 2 all together. Okay, I think I missed 1 2 2 1 1 3 3 1 2 3 3 2. That's your relation. So we have total of 3 cases over here, 1 case over here, and this is not this is your R5 actually, 5th. So we have R3 and R4. So total of 5 such relations. Answer is 5. Option A is correct. Getting it? Just reflexive will also be a equivalence relation. We can keep one symmetric relations like this, 1 to 2 1 with the reflexive also becomes equivalence. We can have 3 cases as such, and we have 1 case of all relations, all elements related to each other. Okay, in all possibilities. 7th is done. Question number 8 now. 7th was very easy. Yes or no? Very easy question. 8th one. Against the PYQ. It's not a question that I have made or taken somewhere else. It's a PYQ from one of the years of 2024 and 2025. Let A is 1 to 3, the number of relations on A containing 1, 2, 2, 3, which are reflexive, transitive, but not symmetric. Okay. Alright, we have to write the relation now, right? On the, it should be reflexive. It means I should have, first thing is very simple, 1, 1, 2, 2, 3, 3. That's correct. We should also keep 1, 2, because the thing containing 1, 2, and 2, 3. Okay. For it to be transitive, it means I should also have 1, 3. Please check here. 1, 2, 2, 3 means I should have 1, 3 also for the transitive. So 1, 3 is also there. 1, 3 is also there. Okay. Now we don't want symmetric, right? Okay. We don't want symmetric. So what is left now? We have 2, 3. No, we have 3, 2 left, and we have 2, 1 left. That's all. We have 2, 1 also left, and 3, 1 also. Okay. So we have 1, 3. We have to take. Okay. So let's take case 1. We can take here 2, 1, okay, but we'll not take 2, 3, sorry, 3, 2. We'll not take 3, 2. We can do that. We'll take this in and this out. This is one case, okay, and all right, reflexive and transitive, 1, 2, 2, 3, yeah, 1, okay, correct. So second one, what we're gonna do, we'll have here. So we'll not take 2, 1 and we'll take 3, 2. So think about it. It's going to be what? It's going to be, again, this part is not coming, this part is coming. So this part is symmetric, but this part is not symmetric. It means the total relation will not be symmetric in nature. Third case, we can remove both of these. Okay. Total of 3 cases we have. Answer becomes 3. Answer becomes 3. Please check. Okay. Again, question number 8 is also done. Moving on to question number 9 now. Let R is 1, 2, 2, 3 and 3, 3. Let be a relation or defined on the set 1, 2, 3, 4. Okay. Then the minimum number of elements needed to be added in R so that R becomes an equivalence relation. Minimum number of elements to be added. So for it to be equivalence, we have to make it reflexive first. I don't have 1, 1. So let's write, to make it reflexive, I need 1, 1. I need 2, 2. I need 4, 4 also, because I already have 3, 3. Already have 3, 3. Okay. Now you want it to be 1, 2, 2, 3 is there. It means I need 1, 3 also. Think about it. I have 1, 2 and 2, 3. It means I need 1, 3 also. Correct. Now if we want transitive as well, 1, 2, 2, 3 means 1, 3 also should be there. We want symmetric as well. So we need 3, 1. We need 3, 1. Okay. And since we have 2, 3, it means I need 3, 2 and I need 2, 1 also. I need 2, 1 also. Right? Yeah. So it gets what? It becomes 1, 2, 3, 4, 5, 6, 7, right? These are the to be added. So nothing but to be added for what? For the equivalence relation. Your answer is nothing but 7. Option A, 7th is correct. Option A, 7th is correct. So you need to add these 7 elements, minimum these 7 to make it equivalence relation. You can add more also, but minimum they're asking, right? They're asking minimum number of elements. So these are the minimum 7 elements to be added to make it minimum. First equivalence should come after adding this 7 elements. Works out? Of course, right? This is for the reflexive part. 1 3 because of the transitive over here. 1 3 there means you have to keep 3 1 for the symmetric part. Since we have 1 2 means I should have 2 1, and should have 2 3 means we should have 3 2 also for the symmetric part. Getting it? Okay. So 9th is done. Question number 10 we can solve. Easy. Question number 10. Let x be x equals to r cross r. Define a relation R on X as A1 B1 R A2 B2. See here the relation, the X Y, usually we write the relation as this, no? X R Y. Here X and Y is also a ordered pair. What's the ordered pair here? A1 B1 and A2 B2. A1 B1 and A2 B2. Okay, great. So they're saying that if that is the case means we get these two equal to each other. We get B1 equal to B2. Great, no problem. So in that particular case what we have a look. B1 equal to B2 we have R is equivalence relation. Let's check for that. Okay. So if I take reflexive first, if I check for reflexive first, we can write this as A1 comma B1 R A1 comma B1. Correct, no? That's how we write the reflexive ordered pairs. This has to be equal to this. Check this out. We have B1 equal to B1. That's correct. That's true. It means reflexive is possible. Let's move on to next. Next is, sir, what? Next is symmetric. Next is symmetric. Okay. So we have A1 B1 and A2 B2. Okay. So it means that is correct. If I have to change it out, I get A2 B2. I'm reversing the ordered pair, right? So we write here A2 comma B2 R A1 comma B1. Check from here. What we're getting? We're getting B2 equals to B1. That's correct only, no? If we have B1 equal to B2 from the first statement of the symmetric relation, from second we're getting B2 equals to B1. That's true only, right? B1 or B2 or B2 or B1, the same thing, okay? Symmetric also is true. Check for transitive now, okay? So we check for transitive now. We'll check from over here, okay? Checking for transitive now. Transitive, please check. So we have A1 B1 R A2 B2. From here what we're getting? B1 equals to B2. Next we're gonna write what? A2 comma B2 R A3 comma B3. From here what we're getting? B2 equals to B3. This is equation number 1 and equation number 2. Please check. Okay. There are two if statements for transitivity. A1 B1 A2 B2 A2 B2 A3 B3. Okay. From equation 1 and 2 you can see B1 and B3 are also equal because B1 equals to B2 and B2 equals to B3. It means simply we can say from 1 and 2, please check, B1 equals to B3. Now same way I can write the relation also over here. So look like this. A1 B1 R A3 B3. A1 B1 R A3 B3, which is correct only, no? In this particular case what I'm getting? I'm getting the validation of your transitive relation. It means transitive also is true. So given relation is, what is it? It's a reflexive, symmetric and transitive. It means it is going to be a equivalence relation. It's going to be, the relation is equivalence. Relation is equivalence. That's true. This much is clear. Okay. Now next statement. So statement 1 is true. This is true. 2 you check. For the relation statement number 2, what we have, okay, for some AB belongs to X, the ordered pair X from the set X, the set S is defined in such a way that XY and RAB represents a line parallel to Y equal to X. Okay, Y equal to X. That's your line, Y equal to X. Parallel to this, what is that line? Please check from here for what you're getting. The line is Y equal to B, right? The relation you check over here, what we get? This equal to this. Compare here, Y equals to B. Y equal to B is a constant line, sir. Like this. This is your constant line, Y equal to B. Can this line be ever parallel? Wherever you take, whether you take over here or you take over here, Okay, y equal to b2 I can take. Okay, anything I can take. Okay, it'll always be intersecting in nature. It'll never be parallel. Okay, but they're asking for what? They're saying it is going to be representing a set of parallel lines. Not possible. It means statement number 2 is wrong. It's wrong. Okay, so our answer is statement 1 is true and 2 is false. Answer is statement 1 is true and 2 is false. 1 is true and 2 is false. Option A is correct. Please check. Option A is correct. Okay, moving on to next question number, which is 11th. I hope this is all clear. How did we prove symmetric, reflexive and transitive, and how did we prove the lines are not parallel? Okay, clear. Question number 11 now. The relation R defined as x plus y, okay, such that x and y belongs to the integers z and x plus y is even. Okay, let's check for. Okay, again equivalence relation we have to check for. Okay, so we'll have here for reflexive, we'll get what? X r y, right? X r y. So no, reflexive means x r x I get. Sorry, I get x r x. So it becomes what? X plus x. How much is that? 2x. Clearly even. Clearly even. It means reflexive is correct. Correct, no? X plus y is even. Have a look. X plus x is going to be 2x, right? This is going to be 2x. It means, of course, it's going to be even, right? Okay. Symmetric, we have x r y, which means x plus y is given even. Okay. Let's move on to the next one. Y r x, which becomes y plus x will also be even. If x plus y is even, means y plus x is also even. Is also even. It means the case of symmetric is also true. Think about it. This is the if statement. This is if. Okay. This is then statement. Okay. If x r y is true, y r x also has to be true. Okay. Next is what, dear? Transitive relations. So for this, what we have? Take here x r y, y r z. Okay. These are the if statement. I should also get x r z from here. You can do it. We get here x plus y is even. From here, what we get? Y plus z is even. Add these two. What I get? I get x plus y plus y. How much is that? 2y. And plus z. Going to be what? Even. If you add any two even numbers, 2 plus 16, 18, again an even number. Any even two even numbers you add, it will be resulting into another even number. So x plus y and y plus z you are adding. Okay, you get x plus 2y plus z is also even. Please check from here. I'm getting here x plus z plus 2y is even. From here, what are you getting? Please check. You're getting 2y is actually even. Can you add odd number to even number to get even number? Can you add an odd number to another even number to get another even number? Can you do that? Can you add 2 to 3 to get even number? Never. It means if the result is even, this is even, it means this also has to be even. It means x plus z is also even number, sir. It's also even number, sir. What it means is basically, it means the relation x r z also holds true. From where? From here. It means also transitive relation. Also a transitive relation. So we're getting here the relation R to be reflexive, symmetric and transitive, hence equivalence. Hence equivalence done. Have a look. This clear? This is clear or not? Is it clear or not? Of course it is. You let me know if there is a problem in the comment section. Sir, I forgot, I did not get how that to do that question. I'll come to you with a resolution of that. Okay, let's move on to question number 12 now. Okay. Define a relation R on the interval 0 to pi by 2 by x r y. Of course, the ordered pair is x r y. If and only if this condition is validated. Let's check it out for reflexive now. So we have to take x r x in this case. Okay, so we'll have over here sec square x minus tan square x. We know that it is always 1. It's an identity, right? We learned in grade 10. of CBSE, grade 9 of your ICSE boards. If you were there, if you were in PU, again grade 10 you have learned. Okay, so sec square minus tan square is 1, is the identity of trigonometry, so it's true. Reflexive is also true. Moving on to symmetric. For symmetric, we have to take here XRY is true. What it means is, it means this condition is given to us. So we have sec square x minus tan square y equals to 1 is given to us. Okay. From here I want to prove that sec square y and tan square x is also true. What I'm going to prove? Sec square x will become sec square y minus tan square x will become, the y will become x. Okay. How do you do that? Convert this into terms of tan. So what we get over here? Sec square becomes 1 plus tan square x, and this will become minus sec square y minus 1, sec square y minus 1. Of course there is a equal to 1 over here. Simplify this. So we'll have 1 plus tan square minus sec square. So I'm getting here tan square x minus sec square x. Please check. 1 here and this one. This one and this one becomes 2. How, sir? We have minus of minus. So becomes 2. Right here plus 2 equals to 1. Move this statement on this side and this 1 on this side. I'm getting here 2 minus 1 is how much? 1. And this gives me sec becomes positive. So sec square x is positive minus tan square. Excuse me. Something I've made a mistake with. I think this would be y. Right? Yeah, y. It will be y over here. Done. So it means symmetric also. Started with sec square x minus tan square y equal to 1. What are we getting? Sec square y minus tan square x. This is representing what here? Y r x. This was x r y is true. I'm getting y r x also is true. Okay. Next, moving on to transitive relation. Okay. So for this we'll have to take. We have to take 3 elements over here, right? So we can write, for one thing we can write from here only directly. Please check. I'm going to make use of this. From here, what are we getting? So move this statement over here. Okay, not this. From here. Move it over here. What do we get? We get sec square x equals to 1 plus tan square y. So sec square x equals to 1 plus tan square y. Okay. So 1 plus tan square is how much, sir? This is going to be sec square only. So I get here sec square y. Basically, I'm getting sec square x equals to sec square y. Sec square y. Now for the statement of that we have, so please check. We should have x r y. We should have, this is x r y, right? This is x r y. Okay. And we should have y r z. Check y r z. So we'll have over here sec square y minus tan square z, right? Tan square z equals to 1. Okay. Sec square y is how much, sir? This you can replace this by sec square x. So this what I've written over here in the first statement is x r y. Y r z I've written over here, y r z. I'm going to replace x square y from here in terms of sec square x. Please check. Okay. So this whole thing will become, sec square x actually. Instead of this, I'm writing this, x square x minus tan square z equals to 1. This is nothing but, if you check carefully, is nothing but x r z. X r z. This is t, sir, actually. This is t. Okay. I had x r y. Y r z means x r z also true. Hence, also transitive option is A. Reflexive. I hope this is fun and clear. Very much simple. Had fun. Have a look. We'll begin the next question. We'll start again. Question number 13 now. Okay. So let S equals to 1, 2, 3, 10. Okay. Suppose M is the set of all subsets of S. All subsets of S. Okay. R equal to A. The relation is defined like this. R equal to A comma B. A and B has the intersection of that is not a null set. Means there will be always an intersection of A and B. Means in A and B intersection, okay, there will always be something validated. Like it cannot be equal to null set. Means always have something common. Have something common. Always have something common. That's what it means. Okay, not equal to null set, it means always have something common. Great. So all right, this is clear. Have something common. Great. Looking for the reflexive relations. What type of this is going to be? Let's start from reflexive. So we know that even, so I understand that M is a subset of, so M is a set of all subsets of the relation S. So you have the set S, okay. M is a subset of all the subsets, okay, set of all the subsets. But even phi will be a subset of M, right? Correct now? And if you look for intersection of phi with phi, what are you getting? It will equal to phi, right? Correct or not? All the elements which is there of the set M, okay, phi is also part of it, because phi is also, null set is also a set of, null set is also a subset of any element, any set, okay. Null set is also a subset of, always a subset of any set. In that case, phi intersection with phi will be equal to what? Phi, which cannot be the case. They are saying that cannot be equal to phi. Cannot be equal to phi. It means not reflexive. Understand this? Phi is also subset of any set. In this case, the set M. So if we take this condition, phi intersection with phi, I am getting the result as phi. So which is not the case over here, which is given. They should always have something in common. Saying nothing is common means not reflexive. Look for symmetric now. Symmetric, please check. So if I say A intersection with B is not equal to phi, okay, then of course B intersection with A will also be not equal to phi, no? Think about it. If I say two sets A and B has a number 15 as common, okay, set A and B has 15 the number 15 as common element, okay, then of course B and A will also have same element 15 as common, no? Okay, so if A and B is not equal to the null set intersection, then B and A also will not be equal to null set intersection. So both are true means symmetric is correct. Okay, A and B intersection is not equal to null set, then B and A intersection will also be not equal to null set, means they both have something in common. Either you take A and B or B and A, same thing. Okay, now transitive. Okay, so in this case, we'll take examples. Let's take 1, 2, 2, 3. Set A and B I'm talking about. Okay, 1, 2, sorry. Excuse me, this is my set A actually, this whole thing is my set A, okay. Set B right here, 2, 3 and 3, 4. Set C, this is your set B, and set C will be 3, 4 and 4, 5. Set C. Intersection of A and B is how much, sir? We have 2, 3, 2, 3 common. Intersection of A and B is 2, 3, 2, 3 common. For B and C, please check. We have 3, 4, 3, 4 common. So for A and B, what we are getting? Intersection of A and B is not equal to null set, because that is equal to 2, 3. Same way, B and C is not equal to null set because that is equal to 3, 4. But check for A and C. For A and C, do we have something common in set A and set C? We don't have. We don't have anything common, it means is equal to actually null set. In the set A and C, okay, we don't have anything common. It means that it is equal to null set, which cannot be the case. They are saying that should not be equal to null set, okay, hence not transitive. So we have not reflexive, not transitive, only symmetric. Only symmetric. Option D is correct. Option D is correct. Please check. Easy question, just you have to understand the statement clearly. Okay, moving on, next question number 14. This is clear. 14 coming up. Okay, let R be a relation on integers defined by A, B, C, D if and only if AD minus BC is divisible by 5. Divisible by 5. Okay, check for reflexive now. Check for reflexive. What do we have for reflexive, sir? So we have to take here AB, R, AB. Check over here what we're getting. So we're getting BA over here and we're getting AB over here. So multiplication will become AB minus BA, which is that 0, and is divisible by 5. Can we divide 0 by 5? Of course we can. 0 by 5 is 0. That's true. So reflexive, yes. Symmetric, you check now. We already have AB, CD. We'll check the other one. Okay. We'll check CD and AB. CD, R, AB. CD, R, AB. Okay. What I get for this? So I get here BC minus AD, right? Yeah. We get here BC minus AD. BC minus AD. Okay. So if I have AD minus BC is divisible, think about it. If AD minus BC is divisible by 5, okay, then of course we'll also have BC minus AD will be divisible by 5. Think about it. If I write 2 minus 2 minus 12, this is how much? Minus 10, right? Or 12 minus 2. Think about it. 2 minus 12 you write here, okay, or you write here 12 minus 2. You get over here minus 10 or 10. Both are divisible by 5 or not? Yes, they are. Okay. So of course we take AD minus BC or BC minus AD will be both divisible. Of course it means symmetric is also true. Symmetric is also true. Last one, transitive. For this we'll take some examples. Okay. Let's do that. So we have over here, let's say 3, 1, 10, 5. 3, 1 and 10, 5. It's true, right? 10 into 1 is 10, 3 into 5 is 15. 15 minus 10 is how much, sir? 5. Think about it. 3 into 5 is 15 and 1 into 10 is 10. 15 minus 10 is how much? 5. Divisible by 5 or not? Yes, it is divisible. Okay. We'll take another 10, 5 and 1, 1. 10, 5 and 1, 1. Okay. So again I get 5 into 1 is 5 and 10 into 1 is 10. Subtraction of that becomes 5. Divisible. So combine these two, what I get? I get here 3, 1 and 1, 1. Combine now, 1 into 1 is 1, 3 into 1 is 3. Difference of that is 2. Is the number 2 divisible by 5? Not divisible. It means not possible. As I told you, you have to look for one option where it is not applicable. Don't look for 10 options where it is applicable. Sometimes I get this, students comment in the section that, sir, for transitive, I can choose the positive number, I can choose the other number and it's coming right now, sir. Don't look for that. Look for the number which is not possible to find. Even if it is not true for one place, it's not true for all the places. I repeat myself, don't look for the possible cases. Look for where it is not possible. Okay? Think about it. 3, 1, 10, 5, 10, 5, 1, 1, 3, 1, 1, 1. Of course, how will you get to know that? By practice. That is the case. Okay? More you practice this kind of questions, you have more examples coming your way. Do roughly half your way in your mind. Try to do it faster. You get to have the the examples ready with you. Okay, I hope you get it. So you can see over here when I took the example, the first relation I took 3, 1, 10, 5. What I can write like this: 3, 1 R 10, 5. The difference was 5, which is divisible by 5. Here also again I take 10, 5, 1, 1. Again difference was 5, divisible by 5. Here you take 3, 1, 1, 1. Difference is 2. Not divisible by 5. It means not transitive, only symmetric and reflexive. So we have option A is correct now. Reflexive and symmetric but not transitive. Option A is correct. Please check. Option A is right. Option A is right. Okay, moving on. Move on to the next question. Question number 15 now. Okay. Next is, if R is the smallest equivalence relation on the set 1, 2, 3, 4, such that 1, 2 and 1, 3 are part of the relation, then the number of elements in R. Okay. Right here, they're saying equivalence, right? Let's look for first thing which is going to be reflexive. So we have to keep 1, 1, 2, 2, 3, 3, 4, 4. Next they said that keep this also. So we have to keep 1, 2, 1, 3. Okay. We have to keep equivalence means we have to also keep symmetric. So put here 2, 1, 3, 1. Okay. Now think about it. We have 2, 1 and 1, 3. This will make the transitive as 2, 3. We also have to have equivalence, right? It should have been reflexive, symmetric and transitive. So if you keep this 2 1 and 1 3, how did we get 2 1, sir? Because of the symmetric probabilities. Okay, 1 3 will become 3 1, 1 2 becomes 2 1. But you combine 2 1 and 1 3, what do you get? What do you get? You get 2 3. You also keep the symmetric of that, so 3 2. Please check. That's your relation. So we have 2 1 1 3 becomes 2 3, and you have to also keep the symmetric part of that, 3 2. Count it, 1 2 3 4 5 6 7 8 9 10. Option A is correct. Option A is correct. If you want, you can cross check again. You will not have any other cases being formed. Option A, 10 is correct. Moving on, question number 16. I think now the function should come. Yes, the question is on functions. The relations are over. Functions question starts now. The function f minus infinity to infinity is the domain. The range is also given to you, defined like this, looking for 1 1 on 2. Okay. So what we have, sir, here, we can write this function in a smarter way. Okay, because you want to differentiate it, right, to get the 1 1 part. How do you find a 1 1 function? Derivative, if it is positive or negative, only one nature, we can say it is 1 1 or, okay, 1 1 in case. Basically, if I can find derivative is either positive or negative. Positive means increasing function, so again it will be strictly increasing. It means that always increasing means always 1 1. Here also, so either of them. Don't take both. So either this or that, not both. Okay, let's do that. So if I get the fx first, let's do one thing. Take 2 power minus x common. It becomes 2 power 2x, right? 2 power 2x minus 1. This you know, right? You know how to take this common, right? You know how to take this common, I think, right? If you take 2 power minus x common, it becomes what? You have to divide by 2 power minus x in the first term. So you're going to take it up. Okay, it will become 2 power plus x. You already have 2 power plus x, become 2 power 2x. If you're not sure, you can do it like this also. 2 power x minus 1 upon 2 power x. Now take LCM. It will become what? 2 power x. 2 power 2x minus 1 upon 2 power x. Okay. This will become basically what, dear? 2 power 2x minus 1 multiplied with what? 2 power minus x, no? 2 power minus x, right? Same thing I've done over here. Can you check? 2 power x into 2 power 2x minus 1 over here, because of the plus sign that we had over here. Plus 2 power minus x, it becomes plus 2 power plus 1. Okay? This is clear, right? How we got this is clear. No problem? Okay. Now with that known, what we can do is start with the question. So this is cancelled. Now what we have is 2 power 2x. I can write here plus 1, subtract here minus 1, and this minus 1 you keep as it is. Okay. So what I'm trying to do is simply add plus 1 to make this same as denominator. Okay. Please check. I've added extra 1, so I have to remove that part out. That's why I write plus 1 and minus 1, and that minus 1 already present here in the numerator already. Okay. So combine these two together. What I'm getting now? So I'm getting this as f of x becomes equals to, okay, we have here 2 power 2x plus 1 minus 2 divided by 2 power 2x plus 1, which will be nothing but, have a look, divide these two, we get here plus 1 minus 2 upon 2 power 2x plus 1. For all of you understand that very clearly, this is a question from JEE Mains, so they understand that you know the derivatives properly. Okay, I'll try to be very clear in the process, but you have to remember something. I understand that you know that already. Derivative of 1 is how much, sir? 0. It's a constant, so 0. Okay, keep a minus sign. 2 is a constant, keep a 2 also as it is. Now differentiate the denominator. If you keep it in the numerator, it becomes power minus 1, right? If you want, you can keep it like this. 2 power 2x plus 1 power minus 1. Remove from here. Okay, I'm keeping the thing which is there in the denominator in the numerator with the power minus 1. That minus 1 will come over here. Okay, differentiating this, so I get the same thing will repeat. 2 power 2x plus 1 power minus 2, n into n minus 1, the formula. If you have x power n, right, it becomes n times of x power n minus 1. In this case, the entire this x is nothing but this entire bracket 2 power 2x plus 1. Okay, so again the chain rule will apply, true. So we have to differentiate the bracket also inside, so it will become 2 power 2x. What do you have to do? Differentiate of the exponential function. We have a power x differentiation as a power x ln a. So a 2 power 2x ln 2. ln 2. Is it over, sir? No, you differentiate 2x also. So get 2. Think about it. So differentiate 2 power 2x as 2 power 2x ln 2, then differentiate 2x also. Chain rule, we get 2 for that. 2x differentiation is 2. Okay. So let me just erase all of this to have some space. Okay. So I'm getting this derivative very simply as my derivative of x is coming as this minus and this minus will become plus, so plus 2 into this 2. I can write here simply, okay, 4 I can write 4 over here, please check. Correct now? This 2 and this 2 makes 4. The constant ln 2 I also write, ln 2 is also a constant. Then I get what? I get 2 power 2x, okay, and into I can basically divide all of this whole thing divided by what? This part, 2 power 2x plus 1 the whole square. It is power minus 2, right? It comes in the denominator. Power is minus 2 means comes in the denominator as whole square. Please check carefully. Number exponential function which is always positive and a square function always positive means this whole thing is actually coming as positive. This whole thing f dash of x is actually coming as more than 0, always positive. Please check. Okay, it means strictly increasing. It means the function fx is, excuse me, 1 1. The function fx is 1 1. Whenever you have the function to be strictly increasing or decreasing, function becomes, sorry, the derivative to be like that, the function becomes basically what? Always 1 1. Okay, so the derivative is more than 0 means the function is strictly increasing, hence the function is always 1 1 in this particular case. Now check for on 2 case. So let's look for range first. For that we have the domain. So when x tends to negative infinity or positive infinity, let's take, when x tends to plus infinity, what is the fx going to? What is the fx going to? Please check. So fx is moving towards, put here x as plus infinity. Over here we're going to put over here. So if you do that, fx over here, no? Where is the fx? Yeah, right here. It'll become 2 by, no? I had taken this in the fraction. I can write it like this right now again, just to make things easier for us. I'll put it in the fraction form, okay? 2 power 2x plus 1. Okay. Now you put here fx, x as infinity. This whole thing will become infinity, right? So you'll have infinity plus 1. What is this? Infinity. Think about it. If you take 2 power infinity, it'll become infinity only, no? So you'll, because any exponential function, if you see, this is the graph. If you take x as infinity, what's this going to do? This is going to y equals to also infinity, right? So then when this whole thing will become infinity, so plus 1 will become again infinity. 2 by infinity is how much, sir? 0. Dividing 2 by a very big number, how much is that? Almost nothing, so which is 0. So what I get? 1 minus 0. What I get? 1 minus 0. I'll repeat myself, okay? 2 power infinity becomes whole thing infinity. From the graph you can see, when x tends to infinity, this y becomes infinity. This is a graph of exponential function. Now this thing is infinity now. Add 1 to it. Again becomes infinity only. Divide by 2 divided by infinity. Dividing 2 by a very big number becomes what? Almost 0. So I have 1 minus 0. How much is that? 1. 1 minus 0 is how much? 1. Okay. Let me erase this graph part. Not relevant to us right now. Okay. I'll get back to this again. I'll need it, but right now we've just skipped it. Next is when x tends to negative infinity. Check this out. When I get that, what I'm getting? Have a look. So I'm getting over here this function. If you check again the graph part, this is the graph, right? When x tends to negative infinity, sir, over here, what is the y? Almost 0. Please check over here very clearly. This is meaning y is becoming almost 0. It is not 0. It is moving to 0. It is never 0, but it is moving to 0, okay? When x tends to negative infinity, y is moving to 0, okay? So this whole thing is 0. 0 plus 1 is how much? 1. This part becomes, exponential function becomes 0. 0 plus 1 is 1. 2 by 1, how much is that? 2. What this becomes? 1 minus 2, how much is that? Minus 1. It means fx will tend to minus 1. Think about it. 0 plus 1 is 1, 2 by 1 is 2, 1 minus 2 is minus 1, sir, of course, right? Of course, let's erase this just to avoid confusions. Okay, and the graph also. So you can see clearly now what we have over here is your range becomes -1 to 1. -1 to 1 open, not closed. Okay, so your range is -1 to 1 and your codomain is -infinity to -infinity to 1. Your codomain is -infinity to 1, whereas your range is -1 to 1. Okay, you can say here clearly your codomain is not equal to range. It means it's a into function, sir. Into function. It's a into function. Okay, so it is actually a 1 into, we can say 1 but not onto. Option C is correct. 1 but into, or you can say not onto. So option C is correct. Confusing? I hope not. Okay, I really hope not. I've tried to explain it to you. Just understand the graph of the exponential function plays a big role over here. The graph of the exponential function plays a big role over here. Moving on to question number 17 now. This is clear? Okay. Into means not onto. 17 now. f0 to 3 tends to a be defined by fx equals to 2x cube minus 15x square plus 36x plus 7, and g 0 to infinity be defined by gx equals to x power 2025. Okay, and x power 2025 plus 1 if both the functions are onto, and s is this. Okay, s is the x, the element as an integer. Okay, x belongs to either a or b. You have to find, basically you have to find the set a and b. Okay, we're looking for cardinal number of the set S. Answer is, what is the answer they're looking for? Cardinal number of the set S. Okay, start from here. So let's find the set A and B first. Set A, to find the codomain of this. Okay, they're defined like this. All right, they're saying both onto. Why they're saying onto means they're saying that your codomain actually is equal to range, because you can't find codomain. Can you find codomain directly? For a given set, if the codomain is not given, you can't find codomain. Okay, but you can find the range. If it is given onto means they will be equal, right? For onto functions, codomain and range are equal. So let's find the range of each of the functions. How do you find that? We're gonna make use of the domain. Let's find the critical point first. So f dash of x we're gonna find. We'll have over here 6x square minus 30x plus 36. Okay, take 6 common. I have here x square minus 5x plus 6. Factors will be x minus 3 and x minus 2. Correct now? Factors. Minus 3 to minus 2 is plus 6, minus 3x and minus 2x becomes minus 5x, and of course we have x square. So critical points are what, dear? We have 2 and 3 over here, the critical points. And of course we also can take 0 over here because the boundaries are there, na? So we'll find the value of the function fx at all these points. Let's do it. You're gonna find f of 0, f of 2 and f of 3. F of 0 is how much, sir? Put here 0, 0, 0, so 7. F of 2, put here f of 2. How much is f of 2? 2 cube is 8 to 16. 4 into 15 is minus 60 and 72. So plus 72 and plus 7. Okay, so I get here minus 12. So plus 12, 16 will become 28, plus 7 is 35. 35. Okay, f3. Let's find f3 now. Let us find f3 now. So f2 is coming as 35. f2 is coming as 35. Let's find f3 now. So finding f3, I get 3 into 3, 3 power 3 is 27 into 2, 54. Okay, 54. 9 into 15 is minus 35, minus 135. Please check. 3 square is 9 into 15 is 135. So minus 135 and 36 into 3. So 108 plus 108 and plus 7. Plus 7. Okay, so I'm getting here f of 3 is coming as clearly is going to be what, dear? 27 over here, right? 27 subtraction 27 plus 7. Think about it. So we have minus 135 plus 108 becomes minus 27. Minus 135 plus 108 becomes minus 27. From 54 you subtract, you get 27 again, plus 7 becomes 34. Okay, so basically you can see here the minimum value of the function is coming as 7 and max is coming as 35. Okay, max is coming as 35. Why I can say that? Because they are talking about the critical points. Okay, the maximum minima occurs where, dear? The maximum minima occurs when the derivative is put to 0. Okay, so when I put to 0, I get two values, x as 3 or 2. Those are my critical points, and I'm looking for absolute maximum minima, so that's why I've taken here at the boundary 0 also. Correct, na? I'm looking for absolute maxima and minima values over here. So for those extremes, I have to take for boundaries also. Fortunately for us, 3 is also a boundary. So check for the boundary and the critical points. Clearly, I want to say one thing for you, all of you. Why I'm taking for 2, 3 and 0? Because to find the absolute maximum minima values, you learn that later when I teach you the continuity and differentiability part. Okay, we have to find the values at the critical points and the boundaries. How to find critical points? Find the derivative, put it to 0. Critical points going to be, found out from there, and boundary is already given to you. So I found the function value, fx value, at the critical point 2 and 3, and at the boundary also 0 and 3. From there I'm able to understand very clearly. The conclusion is that my range is nothing but minimum value is 7, goes all the way to 35. Correct or not? This is which set, sir? This is the set A. How come, sir, set A? Because the onto function, so codomain and range are equal. Codomain and range are equal. It's a beautiful question. Okay, clear? Moving on. Now check this out. Next is what, dear? So next is going to be for the set B for this function. Let's write it again. So if we can write the function gx clearly in this format, 1 minus 1 upon x 2025 plus 1. How can I do that? Think about it. This you put here as multiplication, minus 1 will again cancel the 1. We'll have the same thing left over here. Okay, alright. So we have the boundary 0 and infinity. Check here. When x tends to 0, your gx tends to what? Think about it. We get here 1 upon, this is going to be 0. 0 plus 1 is 1. 1 upon 1 is again 1. 1 minus 1 is 0. I don't have to write tends to, right? I can write equal to, no? X can be equal to 0. When x is equal to 0, gx is equals to also 0. Clear? Clear or not? Clear. Of course it is clear, sir. Right? X is 0, gx is coming as 0. How do you get that? Put here. 1 upon 0 plus 1 is 1. 1 upon 1 is 1. 1 minus 1 is 0. Okay? But when x tends to, check this out, infinity. What about gx tends to, sir? Think about it. It will become 1 upon infinity, simply infinity. 1 upon infinity is 0, 1. Okay. So my range is going to be what? My b will be what, dear? My b will be 0 enclosed, 1 open. 0 enclosed, 0 is equal to, right? 1 is open. Okay. Now think about it. If I have to combine, if I write the set S you have to write. Let's write in the cardinal form, in the individual elements. Okay. So I have to write 0 over here. Next would come 7. Next would come 8. Next would come 9. All the way till 35. That's your set S or not. For the set S, this is the set S, right? You have to take 0 because we have to take either A or B, but only integers. Z, only integers, either A or B. So in the set B, we have 0 to 1. 1 is open. I cannot take 1. Can I do that? It's not inclusive. It's open. How it is open, sir? Because tends to, x tends to infinity. Fx, gx tends to 1. It tends to not equal to. Clear, right? So for that situation, I can see clearly the set S becomes 0. Then you have to continue with the set A, which is 7 to 35. So 7, 8, 9, all the way to 35. Now what are they asking? They're asking us cardinal number of the set S. They're asking us cardinal number of the set S. How do you find that? From number 1 to 35, how many numbers are there? 35. Right? From number 1 to 35, how many numbers are there? 35 numbers. From 1 to 5, how many numbers are there? 5 numbers. From 6 to 35, how many numbers are there? 1 to 5, 5 numbers. Then 6 to 35, 30 numbers. But we have 7 to 35. It means 29 numbers. I repeat myself. 1 to 35, 35 numbers. 1 to 5 is 5 numbers. It means 6 to 35 is 30 numbers. It means 7 to 35 is 29 numbers. We have 1 0 also. It means total is 30 na sir. Yes or not sir? Yes. So we have 29 numbers over here and we have one number over here which is 0, makes a total of 30. Answer is option C. Had fun? Good question or not? It's a very lovely question. It's not difficult at all. Just you have to use multiple concepts over here. Moving on to next question. Question number 18. Let's start. 18 now. So let fx equals to integration. Good. Including everything over here is coming. Okay, all the way. If you are somebody who's not learnt all of this, I'm trying to explain you in the best possible way all the things, but still you have doubt, you have to wait till when I teach you integrations, then everything will become easier. But these again questions are from PYQs. They can be asked by a mix of concepts, but not that they are not difficult of integration. They're easy integrations, right? They were easy differentiations, not difficult ones. Okay. So 0 to x, they have to integrate this part from 1 to 5. Again the same concept, boundaries. Okay. Integrate this part. What do you get? So you'll have over here t cube minus 9t square plus 20. Integrate this. I get here t power 4 by 4 minus 9t cube by 3 plus 20 t was there, no? T square by 2. Okay. So I get here 3 is cancelled over here, 3, and I get here 10. Okay. I'm going to rewrite this by erasing it. This is clear, no? So what we do over here is simply add plus 1 in the integration, right? So we come t power 3 becomes, the formula is this, x power, one second, the formula is this, sir. X power n integration is nothing but, if I have let's say a common letter a over here, I'll keep the a constant outside. X power n we have, what do we do over here? X power n plus 1 divided by n plus 1. Okay, in this case please check, 3 plus 1 becomes 4 divided by 4, 2 plus 1 becomes 3 divided by 3, and the 9 was kept as it is, and we had t, right? So 1 plus 1 becomes 2, so we have t square divided by 2. Getting it? If somebody who has not known integration, I have to cater all of you, right? If you have not known integration, you are just 11th graders moving to 12th, it's okay, this is how you do it. Okay, so let me write this again. So this thing becomes what here? T power 4 minus 3t cube plus 10t square. 10t square. Okay, now I have to use some logic over here. I'm going to erase this. I hope this is okay. I'm going to erase this. Yeah, I'm going to use some logic over here because I don't have to do all the numbers. Okay, I don't have to do all the numbers. Okay, starting from 1 to 5 we're talking about, 1 to 5. Okay, let's try for this. So I'll try for 1, 4 and 5. Reason being, with this I can get minimum maximum easy. So let's find this, the function fx. So basically I'm going to find this f of 1. Put it over here, we get 1 by 4. We get minus 3. We get plus 10. We get minus 7 here, right? So plus 7 here. So 28 plus 1, 29. How we can do the calculation? 10 minus 3 is how much? 7. 7 into 4 is 28, plus 1 is 29 by 4. That's f1. I think this is close to something, 7 point something. Okay, that's minimum only. Okay, if you do 2, you'll get more value than that. Okay, let's find f of 4 now. If I find f of 4, I'll have this as 4 power 4 by 4. So 4 power 3, correct now? Think about it, t becomes 4, right? So it becomes 4 power 4 by 4. 4 power 4 by 4 is how much? 4 power 3. Okay, do it. If you want, you can do the calculation. Put in this part, put this t as 4. Okay, I get here 3 into minus 3 into 4 power 3 and plus 10 into 4 power 2. So 64 minus 3 into 64 plus 160. Okay, I can take 16 common, I think. Okay, no, not required. Please check. 64 minus 3 into 64, I get here 128, right? Take 64 common, you get 1 minus 3 plus 160. So I have over here 64 into minus 2 plus 160. So I have over here what? Minus 128 plus 160. How much is this? 32. That's my f of 4. F of 4. Let's find f of 5 also. Let's find f of 5 also. We want to see which is the bigger one. Okay, I want to find the range value. Okay, because they're saying that range is alpha comma beta. Once I find alpha beta, no, I can use to that the formula that they're asking. I can find easily 4 alpha plus beta. Okay, f of 5 we can find. Again we'll get what? 5 power 4 is how much? 625. Over here we're gonna put 5 power 4 by 4 minus 3 into 5 power 3 plus 10 into 5 power 2. So getting here 625 by 4 minus 125 into 3. 5 cube is 125 into 3 will be 375. Okay, plus 5 square is 25 into 10 is 250. Okay, so if you continue with this, you'll have f of 5. F of 5 will be 624 5 by 4. Okay, and this becomes 125, right? Please check. 250 minus 375 will become 125 minus 125. Multiply, you get LCM as 4. 625 minus 500. So I have 125 by 4 F5. Okay, it's going to be 4 3s are and 4 1 31 point something. This is coming as 31 point something. Which is bigger, sir? This is clearly bigger. 52 is bigger. Okay, so I can say the range is simply coming as, my range is coming as what, dear? Smallest value is 29 by 4. 29 by 4 2. The biggest value is 32. How can I say that? Because I checked for the values 1 2 3 4 5 is there, no? I checked for some odd values. I checked for 1, I checked for 4, and I checked for 5. Okay, that worked out. Now I want what is what I'm looking for. I'm looking for this value for alpha plus beta. Let's do that over here. So 4 times of this. So 4 times of what is it? 29 by 4 plus 4 times of 32. Okay. So cancel, so I get 29 over here plus 8, 12, 7, 5, 1. Answer is 157. Option C is correct. Please check. Yeah, 4 multiplied with B also, beta also. This is the beta value. Okay, this is the beta value and this is the alpha value. This is alpha value over here. Alpha is here, beta is here. You use that to get the range, and you ask looking to find what? 4 times alpha beta. 4 into alpha is what, dear? 29 by 4. Okay, 1 second. Yeah, 4 and 4 is cancelled. 4 into 32 is 128. Answer is 157. Yeah, 9 8 is 17 and 2 plus 2 is 4, 1 5. Option C is correct. 18 is right. Done. 18th done. Question number 19 now. Let's do it. Okay, 19th now. 19th. The domain of the function we have to find out. Good question. Let's do it. Is given in this format: alpha, beta, and gamma. This is gamma actually. Okay, and we're looking for sum of the alpha, beta, and gamma. Okay, let's do that. So we'll apply the condition for these two individually. It's cos inverse and logarithmic function. So for this we know that 2 minus mod of x by 4 has to be what? Between minus 1 and 1. Multiply it. I get here minus 4, 2 minus mod x, 4. Move 2 on this side. So minus 4 minus 2 minus mod x, and we have 4 minus 2, which is 2. Now it's going to be, multiply this with minus sign, becomes plus 6 actually. Right now it is minus 6, no? I'm moving this minus sign also on both sides, minus sign. Okay? And this becomes minus 2. Inequality will reverse if you are multiplying with minus sign. Okay? We know that whenever we multiply with a negative number, the inequality reverses. So greater than equal to. This is less than equal to, right? It becomes greater than equal to. Okay. We have 2 cases over here to solve. From here and from here. Please check. So if you solve for this one, we are getting here mod of x is less than 6. What it means is x belongs to minus 6 to 6. If you check carefully, even this part is incorporated over here. More than minus 2, right? More than minus 2. Check over here, it's already more than. It's minus 6 to 6 will of course incorporate the value of x more than minus 2. Okay, this is one of the part. Okay, this is the domain of the first part. Okay, let's check the logarithmic function. So before the log, what we have 3 minus x cannot be equal to 1. Reason is very simple. Check the power. Here is 1 by x. Power is minus 1, right? It means 1 upon, we have log e 3 minus x. We know that log 1 is 0. We know that log 1 is 0. In that case, it will become, what dear? 1 by 0. If you take 3 minus x as 1, it will become log will become 0. It means it will become 1 by 0, so undefined. Okay. But that's why we're taking here 3 minus x is not equal to 1. Works? Okay. From here, what I'm getting? I'm getting the value of x is not equal to 2. Move this 1 over here and this x over here. We get 1 as negative, x is not equal to 2. One thing is clear. We know that also that log cannot have negative values to operate on. Domain of log is always positive. So 3 minus x is more than 0. It means x is always less than 3. Move this x on this side, na? X is always less than 3. So x is less than 3 and not equal to 2. Use it over here. Combine these two things with this result. What we have, x belongs to, please check, minus 6 closed to 3 open. Think about it. Minus 6 to 3 open, because it has to be less than 3. And remove 2 from the set. Correct, now because 2 cannot be the part of the set. So remove 2 from here. So please check, compare this and this. Compare these two. What I'm getting? My alpha is nothing but 6, sir. Alpha here is 6. Beta is 3, sir. And gamma is 2. Add all of these. 9 plus 2 is 11. Option is C. Option is C. Have a look. Done. Super easy. Question number 19 is done. Moving on to question number 20. 20th karte hain? Let's do 20th one. Okay. 2 questions to go. Let's solve them. Okay. This was clear. 20th question. Let f, g, r2r be defined like this. We're looking for fog. So let's write here fog. We'll define it for both the cases. More than and less than. More than and less than. For more than, what we have to combine? In the x we have to feed g, right? To feed the g, e power x will become e power x minus 1. E power x minus 1. Okay. So what it means is something like this. Exponential function, right? E power x minus 1 will be exponential function. We can remove the modulus, don't worry. We can remove the modulus also. If you're worried about that, positive side, right? This positive side, it will be more than, okay? So, goes like this. That's the part of x more than 0. Graph looks like e power x minus 1. E power x minus 1, okay? So, it doesn't matter. The graph nature, we're not looking for exact graph. This is the nature we are looking for, okay? When I put x as 0, it becomes, 1 minus 1, which is 0 only, correct? So, let's move on now. For x less than 0, we have x plus 1 over here. So right here, mod of x plus 1. There's a minus sign, so put here minus 1. Cancel, cancel, we get here mod x simply. For this, we'll get what? Minus x. Yes or no? We're getting mod x, right? But for x less than 0, we have to open it with minus x. It means the graph is this. Y equal to minus x. This is clear? Clear or not? Yes. Check this out. We have 2 intersections. It means many 1. It means function is not 1, 1. Basically, not 1, 1 function. Clear? What about onto? The codomain is all real. Codomain is all real. And what is the range? Range is only so all real minus negative real numbers. We can't have real numbers negative. Do we have negative real numbers? Do you have any values over here? We don't. So only positive and 0. Okay, only positive real numbers and 0. So basically, from all real numbers, remove the negative real numbers. That is your range. Are they equal? Not equal. Are the codomain and range equal? Not equal. It means not onto. So given function that is given to you is neither 1, 1. The fog, basically, the fog will neither be 1, 1 or onto. Not 1, 1 because of the 2 intersections over here. The graph will have not single intersection, but always a 2 intersection. And onto because the range and codomain is not equal. I hope this is clear. Option is A. Neither 1, 1 nor onto. Neither 1, 1 nor onto. Last question of the day. Let's solve this and complete our session. This is clear? Okay. Let a equals to x comma y, 2x plus 3y equal to 23, x comma y belongs to natural numbers. Natural numbers very important. Okay, and b equals to x comma, okay, b is just the x of the ordered pair xy. Okay, from the set A, then number of functions, one on functions, okay, from A to B. Simply will be n factorial, right? If you can find the n value, what is n? The Carnot number of the set A to B, okay, and they're equal, we can write it, no problem. Let's write it down. So we have for x, can be right here x and y. So you'll have over here, I can take x as 1. 2 into 1 is 2. Check this out. 2x plus 3y equal to 23, right? 2 into 1 is 2. And move this on this side, we get 21 left. So 3 7 is 21. Put it here. 2 into 1 is 2, 3 is 21. Add is 23. 2 into 1 is 2 plus 21 is 23. Correct. Put x as 4. 4 now. 8 plus, we'll have over here 15. So 5. Correct, no? 15 plus 8 is 23, right? Will become 8 plus 15. 23, correct. Okay. Next we put 7. 7 if I put, I'll have here 14. Then it becomes what? 9. Correct, no? Move 14 on this side, because 23 minus 14 is 9. So yeah, correct only. So we have here 7 and 3. Please check. 7 2s are 14 and 7 and 3 3s are 9. So 7 and 14 and 9 becomes 23. Correct. Okay, that's right. Next one will be 1 4 7, and we also have, okay, what else now? We can take 10, right? Yeah, 10 to the 20 and 1. We can take here 10 and 1. 20 plus 3 is 23. So we have, correct, this is it. Yes. So we have, these are the numbers, natural numbers, which combination is possible. So basically my ordered pairs are 1 7 4 5 7 3 and 10 1. This is my what? This is my set A. And set B is what, dear? Set B is simply 1 4 7 and 10. Okay. What is the cardinal number of set A and B? They are both 4. What is NA, sir? 4. NB, sir? 4. It means it is going to be 4 factorial. What is the answer going to be? 24. So your answer, I can write over here. Your answer is nothing but 4 factorial. How much is that? 24. 24. Clear? 4 3 is 24 into 4 3 is 12 into 2 is 24. Answer is 41. No, 4 factorial it is. Okay, it is 4 factorial. Getting it? Answer is 24. I hope this is clear. Question number 21 is done. This completes our session today. So I hope you have enjoyed the session. I hope you learned from it. Let me know your feedback, what you felt about the session. Was it lengthy? Was the explaining good? What do you want me to change? Everything has to be explained or told to me by all of you in the comment section. Okay. Now, if you're worried about some question that you might have, not able to understand properly, it's okay. Leave your concerns in the comment section. I'll get to that. I'll resolve all of it. Okay. One more thing, for the class notes that we are providing, you have to join the WhatsApp channel. Don't worry about the privacy. It's not a WhatsApp group. It's a WhatsApp channel. So once you join that, only we can broadcast it. We can't even see your data. Okay. We can't see your details. You can't post anything. Just receive the content over there. So all the class notes PDF will be provided in that only. Any update about the sessions will be given over there itself. Okay. And if you're new over here, if you're new to the channel and you're looking to have a wonderful preparation for CET, for your examination, competitive examination, what you have to do is simply subscribe to our channel. Okay. We are making a promise that once you are here, once you're committed to us, once you are following our instructions, solving all the questions, you'll have a very, very good result in the next year's batch that we are going to cover up in this entire year of 2026 Sankalp. I hope this is clear. Let me know the session's feedback, what you felt, and that is all for the session today. I'll meet you again very soon. Till then, take care. Bye-bye.